Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 8th, 2025, so just about 4 days ago. This paper introduces a new benchmark that reveals a huge performance gap. An open-source model, Search R1, scores just under 4% accuracy, while GPT-5 reaches over 55%. The paper is titled BrowseComp-Plus, a more fair and transparent evaluation benchmark of Deep Research Agent. And as we'll see, the choice of search tool dramatically changes these results. It tackles fairness issues when evaluating so-called deep research agents, which are LLMs combined with search tools. Also, the authors shared their full implementation on GitHub, and it's not just the code. You'll find a complete benchmark, including the dataset, evaluation scripts, and detailed guides. This lets you reproduce their results, or even plug in your own custom retriever to see how it stacks up. Alright, this first figure really illustrates that key point. It plots model accuracy against the number of search calls. Each model is tested with 2 different retrievers, which are basically the search tools that find relevant documents. The red squares represent a basic retriever called BM25, while the blue dots show a more advanced one, QN3 Embed 8B. For nearly every model, like GPT-5, switching to the better retriever boosts accuracy significantly while also making fewer search calls, meaning the system becomes both smarter and more efficient. So how did they create a benchmark that allows for this kind of controlled experiment? Well, this diagram lays out their 2-stage pipeline for collecting the evidence documents. It starts with a complex question on the left. In the first stage, an automated system breaks that question into smaller clues and gathers potential evidence from web pages. Then, in the crucial second stage, human verifiers step in. They confirm that each clue is justified by the documents, and that together, all the evidence is enough to answer the original question. Okay, this table then details the end-to-end results across many different models and retrievers. You can really see the performance gap here. For instance, GPT-5, a proprietary model, achieves a striking 70% accuracy when paired with the strong QN3 Embed 8B retriever. Meanwhile, open-source models like Search R132B struggle to break 10% even with the best retriever. The last column also shows calibration error, which measures how well a model's confidence in its own answer matches its real accuracy. Building on that, this next table isolates the performance of just the retrievers themselves. It uses metrics like recall at 100, which measures what percentage of correct documents are found in the top 100 results. And IndieCG at 10, which scores how well the most relevant documents are ranked. The difference is stark. For evidence documents, the basic BM25 retriever has a recall at 100 of just 4.7%. In contrast, the QN3 Embed 8B model hits nearly 48%, showing it's far better at finding what the agent needs. So, the big takeaway here is that BrowseComp-Plus successfully isolates the different parts of a research agent. It proves that the quality of the search tool is just as critical as the LLM itself. A better retriever directly leads to better, more efficient answers. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.